Welcome to class, guys. Have a seat. Alright. What's that? Oh, I'll pass them out. I'll give you some pens. Hey guys, my name's Brian Holmes. I'm a engineer, firefighter, paramedic at Pattonville Fire Protection District. I'm gonna pass out your ERG books and some pens for you guys. Just so you guys know, bathrooms are right outside the door there. There is water if you guys need it. If you guys have questions about anything at any time, just put your hand up. We'll tackle whatever obstacle you have. I sent you guys out a bunch of pamphlets and pre-works to do to get you ready for this class because there's a lot of material to cover. So, any questions before we get started?
No.
No?
No, sir.
Okay. Like I said, if you need a bathroom break or anything, let me know. Phone's off while class is on, unless you guys have some kind of emergency or something. We'll get started. Like I said, we got a lot of material to cover. And we'll get at it. What we're doing today is going over hazmat awareness, analyzing the incidents. We're gonna go over a lot of different things, different modes of transports, how it harms people, how to identify different hazmat material, how to handle that certain material, get you guys used to using your ERGs, which are great tools on calls, different types of protective equipment you need to wear, some different acronyms and things that are really good for at a hazmat situation, and we'll get into it. So the first learning objective we're doing today is the APIE process, which is adopted by the IFF for first responders at a hazmat incident. APIE, analyze, plan, implement, evaluate. Analyze is very important. When you get to the scene or get called to a scene, this kind of sets up the tone of your whole call. You know, chief there's probably looking for different placards, any signs of hazmat spills, anything he can do to try to prepare for the incident. And once you get an idea of what you're dealing with, that's when you implement your plan. Coordinate with other first responders, chiefs, other districts, what kind of equipment you'll need, the hazards, things that potentially affect people in the area, the environment, and then you implement that plan as they're doing that picture there. They got a possible drum spill there, and you can see they implemented what kind of PPE and things they needed to do to tackle the incident. And then as the incident goes on, evaluate, see if you need more resources, the incident's dying down, anything you need to do to close the incident out. So, what do you do to find a hazardous materials incident? In the US, we call them hazmat. In Canada, they call them dangerous goods. So, and here's your causes of potential hazmat incidents. Human error is probably the most likely. Mechanical breakdowns and functions in containers, like in that picture. It looks like I got puncture there. Transportation accidents, as you guys know, there's all kinds of wild stuff traveling on the highways and interstates and things. And some of it may not properly be labeled as well. And then deliberate acts, including terrorism. For your hazmat incidents, these are all things that could involve fires, explosions, danger, extremely difficult to contain depending on the type of hazmat incident, vapors, fuel spills, all kinds of different things. Your specialized equipment is most important for you guys in knowing the proper equipment to wear on the hazmat incident. And then your monitoring equipment, which there is a lot of sophisticated monitoring equipment that helps us as responders on our calls. Learning objective 3 is how these harm people. These are 3 things you must understand as a first responder. The material may encounter the potential health side effects, which there is many, and the associated physical hazards. So acute, chronic, and delayed is what they may affect. Acute is right away. Chronic might be some kind of illness or something that you get that is more long-term, or delayed, which you might not see the effects from the hazmat incident to months or years down the road. These are the 4 types of entry: injection, ingestion, inhalation, absorption. That's why we wear proper PPE. Different mechanisms of harm. Pretty self-explanatory there. The 6 types of energy release: heat, mechanical pressure, electricity, chemical, and radiation. So for your thermal hazards, extreme temperatures, fire, explosions, burns, environmental factors such as heat illness and lack of heat can cause harm as well. Mechanical, from explosions, you could have things, flying objects to the responder or other victims that were at the scene, and simple friction injuries as well: abrasions, blisters, burns. Those are big ones. A lot of hazardous materials are stored under pressure. So depending on different atmospheric pressures or hazards, materials may expand, violent release, and spread quickly. Electricity, that's another hazard that we deal with commonly as first responders. Power lines, utilities, all kinds of different electric equipment, energized equipment at facilities you might go to with a hazmat incident. Chemical energies, like a lot of different materials react differently with different liquids, like when exposed to water, flames, the release of heat. And those hazards might create new and different hazards that you weren't even aware of when you first responded to the call. Energy, radiation is one that you're not going to see, but it is extremely harmful depending on the type of radiation. And these are some places that you would have to think about when you're responding that could have that, medical centers, industrial operations plants, power plants, research facilities, terrorists. I mean, if you got hospitals in your area, we have a large area over here that does a lot of medical manufacturing in our commercial area here that we have on our pre-incident plans. So when we go there, we know it's a possibility of radiation exposure. States of matter, it's very simple, but it's very important to know for your hazmat responses. Solid, liquid, and gas, as you see in the pictures there. Heat has a lot of effect on temperature and pressure, as the diagram shows. When things heat up, pressures expand, and that can cause levees, which we'll go over, and ruptures and tanks, all shapes and sizes. So, and I definitely agree with this. Incidents involving gases are potentially the most dangerous, especially if you're not wearing proper PPE, inhalation. That can cause a lot of acute, chronic, and injuries. And that's the thing too. Some of these chemicals don't have odors, so you might be inhaling them and not even know it. So, a very good warning that just because it doesn't look like there's a hazard, but if you don't go in with proper SCBA and PPE, you might have a gas released in the area that you don't think is toxic to you, but it might have dropped the oxygen level below normal ambient air that can potentially be fatal. Obviously, these are the hazards of gases: breathing, inhalation, and contact. And here's a couple examples of placards that we'll go through later, and their potential hazards. We can find that out in our ERG guide. Some examples of liquids: you got simple oil dry cleanup liquid. You got a hazard going into looks like a small water area for some agriculture, and then you got a gentleman over there making a dam to prevent further hazards from a liquid spill. So these are usually visible. Most times, depending on the amount and type, you will have to contain and confine them. But don't travel as far as gas normally. Just a couple examples of you know, he's wearing his proper PPE. I wouldn't recommend stepping in the hazard. That creates a whole lot of new problems. And then even though the liquid's spilling out of the barrel, it's letting off vapors, still creating vapor hazard. Here's examples of solid hazmat. Different particle sizes influence behavior, influencing cleanup, how far the particle's gonna travel, but they typically remain in place. So usually detected visibly, may sublime, usually confined to a limited area, usually, not at all times. Less likelihood of undetected travel as well. So here's our learning objective 5, explain physical properties that aid in identifying potential hazards and predicting behavior of hazardous materials. Characteristics that do not involve the chemistry or chemical nature of the material, and then describe how materials behave in relation to physical influences or how a material behaves when mixed with or compared to another material. And we'll touch on these a little more, but these are all different physical characteristics that can greatly affect your hazmat incident. Normal atmospheric pressure is 760, so gases under those will remain gases under normal conditions. The higher temperature of a substance, the higher its vapor pressures will be. So like I said earlier, temperature greatly affects your hazmat incident. And like I said, use that atmospheric pressure of 760 for your baseline measurement. The lower the boiling point, the higher the vapor pressure will be. These are all really important to know on your hazmat incidents because it's going to affect your possible evacuation areas, who's affected, you know, and then the weather comes into play as well. Another diagram of, you can see the hotter it gets, the higher the vapor pressure. It's going to put off more possible toxic fumes if you're at a hazmat incident. Boiling point. So boiling point for us in the States, we use Fahrenheit is 212 at sea level. So it's what temperature at which a liquid changes to a gas at a given pressure. So that's for water, obviously, but all chemicals are going to have different boiling points. So levies, these are very dangerous situations when you have liquid in the container and it's heated too high, it starts to boil and vaporize, and then its pressure exceeds the pressure that the container can hold. And like it says, those can be catastrophic, and they do expand rapidly and possibly ignite. So you have your melting point, freezing point, and sublimation. Melting point is temperature at which a solid changes to a liquid at normal atmospheric pressure. Then you got your freezing point at which liquid becomes a solid at normal atmospheric pressure. And then sublimation is substance changes directly from a solid to a gas without going into a liquid state in between. Vapor density is also very good to know about your hazmat materials. If you know the material you're dealing with, you can tell where it's going to be at your incident. Like chlorine is greater than 1 on the vapor density, so it's going to go below normal air, and methane is greater than 1, I'm sorry, so it's going to sink, and like methane's less than 1, so it's going to rise above normal air, just like the balloon diagram shows. And just touching that again, gases with vapor density less than 1 will rise and spread. 1's greater than 1 will sink and displace oxygen at low levels. That's why it's important to have your SCBAs and your PPE on. So, you know, the heavier the gas, more likely it is to concentrate in a low place and may create fire hazards. And temperature comes into variation with density. So it's always good to possibly on the way to your call, get your wind direction, your temperature, things like that from dispatch if you can. Personnel cannot precisely predict the spread of vapors from vapor density. There's just too many factors, and you just do the best you can on that. Solubility, percentage by weight, material will dissolve in water at ambient temperature. Affects whether the substance mixes in water, because not all substances do mix with water. Solubility information can be useful in determining spill cleanup methods and extinguishing agents. So water-soluble liquids will mix with water, non-soluble will not. And that's gonna come into play depending on your material, how you can clean up the incident or contain the incident, or how far it could possibly spread. So you can see in that one where that's not water soluble, it's not mixing together with the water. I'm assuming that's probably gas, but I'm not totally sure. Water solubility and symptom development. Water soluble irritant agents usually cause early respiratory tract irritation and then result in coughing and throat irritation. Ammonia would be a good one if you guys have ever had to run into that. That makes you cough immediately if you're not wearing the proper PPE. Partially water soluble chemicals will penetrate into lower respiratory system, and then you might not even know for 12 to 24 hours, and you'll slowly just get symptoms, and you definitely need to seek medical attention right away. Miscibility, so miscible equals liquids or gases that mix or dissolve into each other. Immiscible, incapable with being mixed or blended with another substance. Specific gravity, it's another good one because it's the ratio density of a material to the density of a standard material. Solubility plays a role in this as well. So most flammable liquids float on water, as you guys saw in the couple slides ago. Like I said, I'm assuming that was probably gas, not mixing with the water, sitting on top of the water. Persistence is usually related to how long it takes a hazardous material to break down on its own, and definitely don't step in it and spread it through the environment, or to yourself, or to your loved ones, or everybody back at the firehouse. Viscosity, thickness or flowability of a liquid at a given temperature, sometimes described using numeric values, determines ease with which a product flows, which can greatly determine if you have a spill or a leak, how big the affected area is going to be. Greatly affected by temperature. High viscosity liquids tend to have to be heated to increase their fluidity, like heated up oil. Like when oil's cold, it pours out a lot slower, but when you drain it out of your motor, it comes out a lot faster if your motor's warm. Viscous materials tend to be more persistent and have lower vapor pressure. SDS seats, you'll find these at a lot of manufacturing plants, places of business, commercial, industrial. Typically contain description of material's appearance, quickly provides information about substance, state of matter, and potential behavior. So detecting a substance by appearance, evaluate change in appearance, which may indicate behavior change. Colors may vary significantly with an industrial product. Significant color difference may show contamination or high levels of hazardous impurities. If you can get your hands on the SDS sheets, when you go to a call, as long as it's not in the hot zone, it's a very good tool that can be very specific to the hazardous materials you're dealing with. Odor, not always a great sign to go by, or a great sense to go by, because like I said, a lot of hazardous materials don't have an odor, such as carbon monoxide. Some chemicals have little or no odor, others have strong characteristics odor, and we'll touch into this later with the placards, but you can see that is labeled quite well, so you kind of know what you're dealing with. Petroleum gas, and you got your 1075 for your ERG guide, so that would be very helpful on knowing what to do. And it even tells you it's non-odorized. If you can smell a chemical, you are exposed. Move out of the area and reassess the situation. So yes, notify through chain of command what happened, and they'll take the proper steps of deconning you and looking at possible reactions to whatever you were exposed to. Never use odor to determine safe or unsafe areas. Touch on this again. Everybody's sense of smell is different, especially if you got a nasty sinus infection or something. You're not going to be able to smell anything. Odor threshold, concentration at which the average person can smell a particular compound, but it's nothing to go by. Like everybody's odor threshold is completely different. But it is, if you do smell something, remove yourself from the area. Objective 6 is explain chemical properties that aid in identifying potential hazards and predicting behaviors of hazardous material. These are all good. Flammability, corrosivity, reactivity, and radioactivity, and we'll touch on these. Most hazardous material incidents involve flammable materials. Flammable materials can damage life property when they ignite, burn, or explode. Use hazards, flammability to help determine strategies and tactics. That's going to set up your isolation zones, what you can use on the flammable liquid, what type of CO2, dry chem, foam, water, whatever it may be. Your flash point, minimum temperature at which a liquid or a volatile solid gives off sufficient vapors at its lower explosive limit, your LEL, to form an ignitable mixture with air. And most places do have monitors with LEL, so that's always a good tool to have. Material vapors will flash in the presence of an ignition source but will not continue to burn. Do not confuse with fire point. Only the vapors burn, and a substance not at its flash point will not burn. Flammable gases have a low flash point, so they are flammable all the time. It's definitely something to remember when you go on calls. Auto ignition temperature, the minimum temperature to which the fuel and air must be heated to initiate self-sustained combustion without initiation from an independent ignition source. So whether if there's nothing there to light it, if they hit a certain temperature, it's gonna ignite on its own. You can't just get rid of the ignition source. You'll have to somehow cool the hazardous material depending on what it is. Considerably higher than flash and fire points. So, like we kind of went over the LEL here. There's your upper and lowers right there for different acetylene, carbon dioxide, ethyl alcohol, fuel number 1, gasoline, methane, and propane. I mean, you can see how they vary. I mean, look at the differences. And like it's talking too lean in the weight, won't combust, too rich, but once it hits that range, and every chemical or hazmat situation, they're all going to be different ranges for that, just depending on what your material or fluid you're dealing with. Corrosivity, here's an example of your pH scale. I mean, distilled water, right at a 7, and it gives you some other examples of that. Going either way on this is bad. Like I said, battery acids of 1, very acidic. Lye, sodium hydroxide, very alkalotic, and they can, especially if you come into contact with those really high or really low on the pH scale, it can severe burns and do some serious physical damage. That's why your PPE, SCBAs are so important. Reactivity, substance's ability to undergo a chemical reaction with itself or other materials. So there's your reactivity triangle. Just kind of gives you an example of each one. Your energy is heat, shock, radiation, light, the fuel, and then whatever oxidizing agent you may have involved in that. So 9 reactive hazard classes. Highly flammable, explosive, polymerizable, strong oxidizing agent, strong reducing agent, water reactive, air reactive, compound, radioactive material. Those are all things your ERG will help you with as well, and the placard, hopefully you can get a placard off the material that can provide you with this information. Example in your ERG guide, polymerization, the chemical reaction in which simple molecules combine to form long chain molecules. And I know you guys touched on those before class in your guides. We'll go through a couple scenarios later, but there's your P that indicates for polymerization. Inhibitors are things that are added to products that easily polymerize in order to control or prevent an undesired reaction. So during transport for safety measures, they'll add these to whatever fuel that is, or liquid, or what they're carrying to reduce the risk of that. Ionizing radiation, you can see there's alpha, beta, gamma, and then your neutrons. Alpha, you have to actually touch it to be exposed to it. It's stopped by skin. You know, beta, not as hard to block that. Gamma, I mean, you're getting up to where you have to be standing behind lead to stop gamma rays, and then neutron is a certain thickness of concrete to block those. So, and you don't see those either, but if you're getting exposed to it, those are things that can cause different long-term, acute, chronic types of injuries. So your radioactive material, your RAM, your exposure is RAM emit ionizing radiation. Incidents are uncommon. Exposure occurs when a person is near a radiation source and is exposed to energy from that source. A person may receive a dose of radiation based upon length of exposure, energy, and type of source. I mean, everything's got some type of radiation, especially in hospitals. They have a lot of equipment that use x-rays, things like that use radiation. Contamination occurs when radioactive material is deposited on surfaces, skin, clothing, or any place where it is not desired. Exposure alone does not contaminate a person, and then internal or external contamination, like as you saw, those rays they can actually cause damage to your internal organs, and you may not know for a long period of time. So like I said, sometimes the damage can be very delayed. Radiation health hazards. Ionizing radiation affects operation of cells. That's kind of just what I talked about. Many damaged cells may cause health effects, including genetic mutations and cancer. Biological effects depend on how much and how fast a dose is received. So that's why it's always wear the proper PPE, proper shielding when you're responding to these incidents. Acute dose. Received in a short period, usually a large dose, can produce serious health effects. And extremely high doses of acute radiation can result in death in a few hours, days, or weeks. This happened when they were developing atomic bombs. Chronic dose, small amounts of radiation received over a long period of time. The body is better equipped to handle a chronic dose than acute. The body has enough time to replace dead and non-functioning cells with healthy ones. Do not result in the same detectable health effects seen with acute doses, but it may also cause cancer as well. Time distance and shielding is definitely your friend in these scenarios. I mean, even that example, they're using the fire truck as a shield. And being in the hot zone there would be interesting. Let's see. But there's your 3 different zones as well. And you'll never be in the warm or hot zone without your proper PPE and for that incident. The biggest thing you can do is limit your dose, limit your time, maximum your distance, and use shielding. That is the best thing you can do in those radioactive incidences. Toxicity. The systemic effects of toxic materials may be absorbed into the bloodstream and distributed to other parts of the body. Adverse effects such as seizures or cardiac and pulmonary problems, or single or multiple systemic effects are possible. So just because you get the dose in a certain area, it may spread to your different organs and different parts of your body. And here's your different types, things that toxicity can cause. There's irritants, asphyxiants, carcinogens, allergens and sensitizers, and convulsants. The irritants is definitely the most common. The carcinogens is, once again, more of a long-term thing that you may not know for years down the road after you were exposed to something. And once again, you can see they're labeled very well. Especially in these instances, binoculars are a great tool, so you don't have to get close to incidents to see what you're dealing with. Toxic and carcinogenic products of combustion and smoke. This isn't only on hazmat calls, but every house fire, car fire, anything that you go on. I mean, they are hazmat calls just the same. And hydrocyanide, carbon monoxide, and carbon dioxide. Once again, your SCBA and PPE, extremely important those, and deconning properly afterwards. Biological hazards, viruses, bacteria, rickets, and biological toxins. There's an example of smallpox there, anthrax, botulisms, and that's mostly how you're going to see those. Unfortunately, people still want to use those as terrorist agents. Well, objective 7, explain the role of the general hazardous materials behavior model in predicting the behavior of containers. And there is a lot of different types of containers for hazardous material. Hazardous material and container behavior generally follows a pattern. Things that can escape from their containers and hurt or harm things they touch is a hazardous material. Common elements of a hazardous material are materials presenting hazards to people, the environment, or property. Containers that have failed to have potential fail. Container or containers that have failed or have potential to fail. Exposure or potential exposure to people, the environment, and or property. This is your general hazardous materials behavior model. Just shows examples of different sequences at a sequence at a hazmat incident. You know, stress on the container, an actual small breach, product releases, the victim or the fireman or the first responder in there, then they get contact, they're engulfed, then they get exposed through their gear to their skin, and then the last one is harm. You got examples of stress on containers, which can be chemical. You see there's some kind of chemical reaction that's pushing that container out. It looks like a drum of some flammable liquid. It could just be the hot day causing the drum to expand, or there could be a chemical reaction in there causing that. You see looks like frost on there. And then your damaged one from just mechanical energy, if that fell off a truck or rolled on the hill, I'm not too sure, but you can see the stress on the container. When evaluating container stress, consider the type of container, the product, type and amount of stress, and potential duration of stress. All things to consider. You have your stress and material state of matter, gas containers, inherently subject to stress, and levees, which we'll go over. That's a very dangerous situation on those. Heating or cooling may increase or reduce the stress, depending on what you're responding to. You might have to cool with water to bring the heat down. Liquid containers may fail and subjected to fires, may also transport materials that polymerize, and uncontrolled polymerization may cause container failure. And then solid containers most likely damaged via mechanical stressors, such as a forklift operator putting a fork through a container, or falling off the back of the truck. Exceptions would include reactive materials from hazard classes. And here's some examples of breach. You got disintegration. Over time, that container rusted and failed. Runaway cracking over there. And then attachments that open or broke. You have this valve here that's been hit or stressed somehow to where it's damaged. There's your puncture and on your breach and your split and tear. Obviously, that's a flammable liquid, and then you can pull up on your, looks like it's possibly corrosive on the end of that container there. And then the release. Contents, energy, and container may release quickly or over an extended period of time. Detonation, explosive release of stored chemical energy. Instantaneous, measured in hundreds or thousandths of a second, so you're not going to have time to react in this if you're anywhere near it. Could result in fragmentation, disintegration, or shattering container, extreme overpressure, and considerable heat. So not only you got to worry about the chemical spreading, and you worry about fire, and then the objects from the container that may be shrapnel after it exploded. Violent rupture, immediate release of chemical or mechanical energy caused by runaway cracks occurs within a time frame of 1 second or less. So something else that if people are nearby, they're not getting away from. Results in ballistic behavior of the container and its contents. Example, levee, which we'll touch on that. And then you got your rapid release, that looks like anhydrous ammonia spewing out of unless it was deliberate, coming out of a possible broken valve. Fast release of a pressurized hazardous material through properly operating safety devices. Occurs in a period of several seconds to several minutes, can result from damaged valves, damaged piping, damaged attachment, or holes in container, or human error. Spills and leaks, slow release of hazardous material under atmospheric or head pressure through holes, rips, tears, or usual openings and attachments. Occur in a period lasting from several minutes to several days. It could be several days because you can't contain it, or it could be leaking and nobody knows. And that could, just depending on its location and how it's monitored. Dispersion and engulfment depends on type of release. Obviously you got some type of vapor there and those cars are engulfed in. Solid, liquid, or gas or vapor, mechanical, thermal or chemical energy and ionizing radiation, and then your product characteristics and environmental conditions, they all affect that. I mean, on a windy day, depending on which way the wind's blowing, that might dissipate the product and make it less of a hazard, or it might push it and make it more of a hazard depending on what the product release is. That's an example of a hemispheric explosion. As you can see, and you see all the different shrapnel flying through the air. So if you're anywhere near that, that's probably going to be fatal. Once again, the cloud, but that's a lot of different factors on that, with weather and time of day and temperature. Same with the plume. And then you got a leak out of a valve causing a cone, almost similar to the anhydrous ammonia tank spraying out. Stream, I mean, I'd say my personal experience is probably the most common thing we go on. Obviously didn't have his backup camera on there and struck the container, compromising it. Pool, depending on the material there, you might be able to dike and dam that and keep it under control. Just depends on what type of hazmat you're dealing with, if you're able to even do that. Irregular, so the truck driver freaked out and drove off and spread the incident, made it even worse than it was to begin with. The three different types of exposures in hazmat and the risk assessment, obviously people, first responders, people that live in the area, workers at a facility, the long-term effects on the environment, and what those hazardous materials could do to it, and they could last years. And the property too, you might have a property that's exposed that is gonna have to be professionally decommed before anybody can return to it, depending on the type of hazmat incident. Exposure and contact, you got your four there: immediate, short-term, medium-term, long-term. Pretty self-explanatory, but long-term, you see it's years, generations. We're dealing with this right now up in North St. Louis County. They're testing all these homes right now from radiation from Coldwater Creek, and they're actually bulldozing homes from that are testing positive. I think they've already gotten rid of 6, I believe, and they're testing like 17 more. So hazmat incidents can last a long time. Is everybody good? Need a bathroom break or drink of water or anything?
Need some water.
You want some water? Go, yeah, take a quick 5-minute break, guys. Get a water.
All right.
Water there, like I said. Bathrooms are right down the stairs. And if you guys have any questions, feel free to ask. It's a lot of material. Yeah, there's stacks over here if you need one. You need something to take notes on or anything, or you good? Quite good. I got extra pads of paper, and you can use my iPad if you want. Use the notepad on it.
Yeah, see that?
What's that?
I'll use that.
Okay.
Candy back there. Looks like candy.
Here, I'll set up the notepad for you.
You could jump on there and.
Type notes in if you want.
That's our
Thank
Wi.
Good, no problem.
Is that the Wi-Fi over there?
Yeah, that's the Wi-Fi password. I sent that to you guys in that little packet I gave you. Sorry, I should have let you know that earlier.
Thanks.
You get connected okay?
Yeah.
Okay.
I can't sit on my hamster with me.
Do you need to stand up? You can. So, once he gets back, we'll, get started. There you go.
Some sugar to get you through this.
All right, everybody good?
Yep.
All right. So, jumping into objective 8, the 7 clues to presence of hazardous material. We'll read those off. These are all very important. Occupancy type locations, pre-incident surveys, container shapes, transportation placards, labels and markings, other markings and other colors for non-transportation, your written resources, senses, and then your monitoring and detection devices. So, little graph there. I mean, the closer you get to the product, the higher the risk. Objective 9, explain how, let me go back to these really quick though. We'll touch on these, but they're all very important. So, explain how pre-incident plan, occupancy types, and locations may indicate the presence of hazardous materials. Pre-plans are things you can, most fire departments and possibly EMS departments have these. You can actually pull them up on the way to your call, so you might know of hazards on the way to the call. And it's just knowing the things in your city, your district that potentially has hazmat material that you'll have to deal with. These are all different types of occupancies likely to have them. I mean, there's a lot, as you can see, even your veterinary office, your feed stores, lumber yards. I mean, lumber yards have a huge fire load. Those are all just big examples of it. Like we talked about medical facilities earlier, hospital. We have a hospital in our district. Fuel storage facilities, even dry cleaners. You almost need to assume there's a possible hazmat material almost at every incident you go to. Other also types, I mean, imagine trying to Imagine what's in those containers, I mean, honestly, no idea. Hopefully they're marked properly. Military installation's a whole nother one as well. Then your residents have hazmat materials, just like shown there. It looks like maybe mineral spirits, gasoline, motor oil, paint. Farms that like them, anhydrous ammonia might be something that farmers use. And fertilizer, which could be a fuel load. So, and that's a good example. If you pull up to a building like that and you see that, it's probably vented for a certain reason. And then your transfer locations, you know, railroads, docks, piers, ports, airplane hangars, truck terminals. Other locations, railways, roadways, waterways, not so much, but like we have the Mississippi, Missouri River here, so that's a potential hazard. And your pipelines. And then, you know, pay attention to the water levels in and around the area. There's a lot of different factors there. If there's a spill, how fast the river or whatever is flowing can spread the product if there is some kind of hazardous material. And being familiar with, I mean, if there's anything that's like on a timetable that you know is gonna be coming through your area, you know, that'd be good to document and let crews know. General container types and their associated behaviors and hazards. Very large containers there. By just looking at them, and it takes a lot of practice on these, but just by looking at these, you can tell if they're pressurized, non-pressurized, flammable liquids, cryogenic, there's all kinds of different things. This would be another good thing if you see these in your area that you work in, get familiar with them, what they process, store, or transport there. You got your highway, rail, water, and multiple modes. You know, things that may come off the rail and then go onto highway. And then your cargo tank trucks, I mean, those are all over the highway. You guys see those all the time. Dry bulk containers, compressed gas tubes, and mixed load containers. These are sometimes very small on these. Hopefully, like if you get to an incident, this isn't damaged, but you can pull very good information off of this container from these DOT specs. A lot of good information there, the capacities, number of compartments, because it might be a long container, but it might have individual compartments in it as well. Highway cargo tanks, non-hazardous materials may be hauled in non-spec cargo tank trucks or trucks designed to meet design specification. That one says agricultural fertilizer. There's a placard or anything else on that to identify it. Your rail cars, you can see 4,000 to 34,000 gallons. That's a lot of product. And you can see up on that end here, you have, that's carbon dioxide refrigerated liquid. Some placards there to get information from. Like I said, hopefully it's in multiple spots and not damaged and you're able to identify it. Low pressure tank cars, it's gonna be the largest ones on rail cars, but you could have cryogenic liquid tanks and pressure tank cars. There's an example of your rail car markings, which like I said, those can also help identifying, and you maybe get in contact with a railroad that is and contact them and give them the ID number and they can help you with what product that is. And then you got your specific markings, very detailed explanation of that. Class number, tank test pressure, type of weld even used, so that's a lot of information on that container. Then you got your freight containers, like you saw the pictures of thousands of those coming in ports and ride on rail cars and even get on the highway as well. They'll move those from the rail cars or from the shipyard to trailers to be hauled. There's your tank containers. Intermodal containers may carry hazardous materials. So not only is it a container, then the container has containers inside that has placards and labels on it. Non-pressure intermodal tanks, pressure intermodal tanks. And like I said, those are all labeled properly. cryogenic intermodal tanks, and then 2 module intermodal tanks as well, with their placards and all their proper markings. And then pressure containers, these are everywhere. I mean, we have them for oxygen for patients, for welding, helium balloons, there's all CO2 for restaurants. These are very common. And then here's your levy process, which I talked about earlier, that is extremely dangerous. So you have a fire on a container, liquid reaches its boiling point, vapors fill container, raising pressure beyond the container's limits, and that's when you get a levy. And that can be very violent and very deadly depending on the product. So contents of pressure containers may ignite easily and will expand quickly if released. Keep your distance upwind, uphill, and upstream. Very good things to remember. And then remove ignition sources if it could be done safely, but don't put yourself in harm's way to do that. More pressure containers. Like I said, these are all over the place. Fixed facility, railway tank car, and highway cargo tank trucks. These are good just to get yourself familiar with them. Some placards on the end of there, your identification numbers there as well, more placards at the end here to help you identify those. Compressed gas tube trailer, your ton container, wide containers, and then more intermodal containers. And then compressed gas cylinders, obviously that one's corrosive and inhalation hazard, so that's not good stuff. Even your simple propane tank that are all over the place, every Home Depot and Lowe's that you go to. And then your vehicle mounted, if vehicles run off natural gas, they'll have those containers on it as well. Hopefully it's labeled properly. Pressure container identifiers, there's always little clues on containers to see if it's pressurized or not. And you can see like the rounded ends, the bolted manways, the bolted at the top, showing you that that's most likely under pressure. And then pressure container identifiers, that one's got its gauges on it to show you the actual pressure in it. And same on the ends here, and then you got your 4 of flammability, I believe that's on there. So common dispersion pattern, levy is going to be hemispheric because it's going to be a violent eruption from that container. Cloud above the container if there's little wind and the release is intermittent or short duration. And then plume, depending on vapor density, terrain, particularly if vapor density is greater than 1 and wind speed. So your vapor density is greater than it's going to rise above normal air. And then cone, steady release of product from a pressure container as it expands from the point of release outward will be directed downwind. Bulk facility pressure tanks, like I said, these are pretty common as well. They're good to know, like I said, what you have in your fire district or city. So I mean, 600,000 gallons, those will hold up to the big ones. So usually liquefied petroleum gas and vinyl chloride, and then above there you have all kinds of different things: hydrogen chloride, LPG, ethane, compressed natural gas. And here's examples of your pressure tank release. That's like a valve fail and it's releasing quickly. Just fittings wear down over time or they rust, or you get your violent rupture, which you see all the shrapnel being thrown in that explosion. High pressure tank trucks, you can see the bolted manways kind of give you a clue that it's a high pressure tank. Inlet outlet valves, wider reflective paint scheme. It's got the rounded hemispheric ends to show you it's under high pressure, and then it's got guard cages to protect those from being damaged, especially on the highway. So they have emergency shutoffs and permanent markings on as well. These are the hazards of those: levy, violent ruptures, rapid relief or leaks, disintegration, runaway cracking, splits, tears, and then your flammable gas vapors may explode, ignite when coming into contact with the ignition source, so very dangerous stuff. A good radius for a high pressure tank fire involved 1 mile in every direction, so very dangerous scenarios. Compressed gas tube trailers, they are a pressure relief device for each cylinder. So not all the cylinders could fail, maybe one just fail and causing the issue, but that might affect the other cylinders as well. They got the bolted manways, valves and protected housings, just like the high pressure ones, and then permanent markings on there as well. Some of the same hazards, the levy, violent ruptures, rapid leaks, the ignition sources come into play. Accidental releases can be violent, and gases will expand rapidly because they're so compressed in those tubes. Pressure tank cars typically transport flammable, non-flammable, and poisonous gases. Also transport flammable and liquefied compressed gases. So a lot of different hazards that could be in these cars, on these rail cars, up to 34,000 gallons in them. Just some different, cylindrical, non-compartmentalized. Always metal, steel, aluminum. They have rounded ends because they're pressurized. Maybe insulated and or thermally protected, maybe. Like you can see the protection got damaged on this car here. Not sure what that was caused by. And there's your hazard, subject to thermal, mechanical, and chemical damage, wheel release, expanded gases, vapors, and then your evacuation areas might be miles. May levy as well. There's your initial evacuation distance for these as well as a mile radius. So, then your pressure intermodal tanks, so up to 500 PSI, usually transport liquefied gases under pressure, maybe damage during transport. Leaks frequently involve the fittings with release of rapidly expanding gases because some of them could be up to 500 PSI. And then you got your heat factors, maybe a levy exposed to heater flames. Ton containers, 1 short ton stored on their sides, ends are convex or concave. These are pretty easy to identify. May have pressure relief devices or fusible plugs. Chlorine containers are often found in locations such as water treatment plants and commercial swimming pools, and we do have a big pool place over here where we have chlorine. So if you have anything pool related that's in your area, that's always good to know. They contain, anhydrous ammonia, refrigerant, sulfur dioxide, typically releases gas or vapors. Evacuating as civilians or responders, being a safe distance is very important, especially on chlorine with that vapor cloud. And it can be corrosive as well. So, structural firefighting gear does not provide adequate protection against the hazardous materials commonly stored in ton containers. So using your ERG or placards, things like that to identify what it is very important, because your normal PPE for a firefighter does not protect against a lot of chemical hazards. Then you got your Y cylinders, Y ton containers, compressed gas cylinders, bulk or non-bulk, and then that's their DOT specification. So you can see those are, hard to read on this, I'm sorry. It looks like an inhalation hazard on there, some type of gas. So, your cryogenic containers designed to store and transport cryogens, may be pressurized. When released, cryogens may transition from liquid to vapor because of the pressure that they're stored at. Vapor clouds may be flammable, toxic, corrosive, or an oxidizer, so that's all bad. Like I said, they may create multiple hazards. Extremely cold and clothing saturated with cryogenic material must be removed immediately, because you can get some serious skin damage and burns and things from that. There you go, you need to remove any clothing saturated with the material. And then more cryogenic containers, railway cars, fixed facilities, highway cargo tanks, just more examples of it. Luckily those are all labeled pretty well. And then some more intermodal cryogenic containers, or more types of the intermodal, your cylinders and your Dewar flasks. So these things come in all shapes and sizes, and even more. So that one is liquid nitrogen there at the top. So yeah, I mean, you can see how these things can fall over and damage valves and fittings and cause an incident. Venting is a function of some cryogenic containers and may not indicate a system failure. It's just probably a safety thing. If it gets a certain pressure, the vent is there to make sure it doesn't exceed the pressure of the container. And there's a very damaged cryogenic container. So released liquids or vapors rapidly boil into expanding gases. So leaking materials can cause the support structure to fail without warning. And then common release occurs through pressure relief devices or leaks from damaged attachments and fittings. So type of dispersions, hemispheric, cloud, plume, pool, which we covered earlier. Some more cryogenic liquid tanks. So these are your bulk facilities. Once again, familiarize the area you respond to. Yeah, you could quite possibly have these types of things there and not even realize it. More cryogenic tank trucks. That was the same one from earlier. So liquefied oxygen, liquefied nitrogen, liquid CO2, and hydrogen are all examples of things they'll transport. They're extremely cold, tend to pool close to the ground, initially visible as a fog or a cloud, typically. As they warm, these liquids will change into a gas state, so your time of day, your temps and everything are gonna come into play on how to handle that hazmat incident. So, more tank trucks, relief valves. Big features of the tank trucks, they got the relief valves, double shelling and heavy insulation. Got the loading and unloading station, permanent markings, and emergency shutoffs. Same thing, mile evacuation involving a fire. May release via violent rupture, rapid release, or leaks, and may levy as well when exposed to heat or flames. More cryogenic liquid tank trucks, that one's on the rail. So anywhere temperature negative 130 degrees Fahrenheit and below. So just more hazards. Tank within a tank. Stainless steel inner tank supported with a strong outer tank. Space between inner and outer tank is filled with insulation and kept under vacuum. Combination of insulation and vacuum protects contents from ambient temperature for only 30 days. So if something gets lost or something shuts down or falls off a truck, somebody doesn't know about it, and sits there that long, that container can fail just from that. So there's the isolation zone for a cryogenic liquid tank is a half mile. More intermodal containers, carry the same stuff. And there's your Dewar flask, a vacuum flask. Non-bulk, non-pressurized insulated container that has a vacuum space between outer and inner vessel, designed for storage and dispersing cryogenic material, but it bulky because of the insulation to protect the product. Liquid holding containers, bottles, gasoline containers, paint pails, drums, all these different things that you might encounter at a house you go to, even for a medical call that you gotta be aware of. And then there's your hazards for those: pressure, heat, reactivity, corrosivity, toxicity, violent rupture, and explosion. More liquid holding containers. You got your access hatches. Low pressure rail tank cars may have multiple fittings visible on the top. You can see across on that one. In the middle, flexible bladders filled with liquid, and design and construction depend on size, mode of transport, material contained, use, and other factors. And different types of low pressure storage tanks there. We got a horizontal tank, cone roof tank for non-pressure tanks. And those can still be very dangerous though, especially people that enter maintenance, fall in the product or things like that. You gotta worry about asphyxiation and confined space stuff as well. More bulk facility. You got your open top floating roof tank up there on the top right, which is very common as well. And lifter roof tank and a vapor dome roof tank as well, and your non-pressure storage tanks. You see they're not labeled very well, so unless you get with somebody that works at the facility or you have prior knowledge of it, knowing what's in there, what kind of product is even in there. And that one's got a big sign on it there. So you know to stay away from there. That's why I was talking about confined space. Not only do you worry about a hazmat issue, but you might become trapped in there as well. Contents may be flammable, contents spill, leak, valves, walls, fittings, attachments, and And then, like I said, treat this interior as a confined space. Even when empty, these containers are likely to have dangerous atmospheres because of lack of oxygen or any other kind of gas or vapor that might be in there. Underground storage tanks. Steel fiberglass or steel fiberglass coatings usually contain liquids classified as low pressure. More than 10% of the surface areas are underground, so it can be buried under or adjacent to a building or driveway. I mean, you got things like gas stations too. You have underground storage tanks full of gasoline. And there's another example of a vent coming from underground. I guess to keep the pressure of that tank in a certain range. So many tanks have been abandoned and may be leaking. That's good to know. Low pressure chemical tank trucks, like you can see that they're properly labeled with placards, which we'll touch on here soon. And there looks like a nice mechanical thing to one of them. So puncture, splits, tears, mechanical. Unlikely to rupture violently involved in a fire or unusual chemical reactions, and more commonly involved with liquids or spills or leaks. Non-pressure cargo tanks, some more examples there. Almost always carry flammable or combustible liquids, so good to know. Fire control is your primary concern on those. So just non-pressure cargo tanks, just some of their ways to identify them if you're on the road. Or not, that one took a hit on something, which most likely Flying J's carrying gasoline. Corrosive liquid tanks, see it properly labeled. Avoid contact with corrosive liquids and vapors, can damage tools, equipment, and PPE. Another example of one there. Small diameter round shape is a good characteristic to remember from those. And you can see usually has rollover protection at the valve assembly to keep those from getting damaged if it does roll over. Corrosive liquid tank there as well. Most commonly involved with spills or leaks. Rarely chemical reaction can cause violent ruptures. Low pressure tank cars, up to 34,000 gallons. Things that they carry. Flammables all the way to fruits and vegetables. Some enclosed fittings on these low pressure cars are inside a protective housing, and then there's all your DOT information that could help you, and that one tells you what it is right there, hydrochloric acid. That's a long line of low pressure tank cars. So transport multiple low pressure tank cars containing ethanol, crude oil, and other class 3 products. So I mean that's a potential there for serious hazmat incidents, huge. You can see all the valves are in protective housing, more DOT to help you identify it. Low pressure intermodal tanks. We touched on those already a little bit. They get up to 100 PSI. So they get moved around a lot, so damage to fittings is not uncommon. Solids holding containers. Many containers used to hold liquids may be used for solids as well. Like we talked about in the last one, they can have petroleum or fruits and vegetables. Fixed facilities may store solids not typically deemed hazardous, but may present a threat anyway. Dust, powders, small particles typically do not carry any pressure. Small airborne particles that burn can be dangerous if ignited in a closed location. And then solid matters can engulf you, causing suffocation or crushing injuries. So here's an example of like a loader into one of the hoppers there, can suffocate you if you get caught under the product. Dry bulk containers, these are pretty to identify on these. The V bottom and the W-shaped unloading compartments usually identifies these. Covered hopper cars, there's uncovered. You guys have probably seen those on the railroads. The dry bulk railroad cars, there's just a lot to learn with all the stuff that goes on rail. So, you know, bags could potentially cause a hazmat incident as well. Radioactive material, accepted industrial type A, B, and C. Radiation can travel in all directions for a long distance and may pass through materials. It cannot be detected by the 5 human senses and requires a meter to detect. Pipelines is a big one. These are everywhere, even through subdivisions, all through the United States, Canada. Natural gas, propane, hydrogen, crude oil, diesel, gasoline, jet fuel, oils, carbon dioxide, anhydrous ammonia, even through the ocean as well. So, but they also may be above ground. Lots of different products are pushed through those, vary sizes and pressure on those pipelines as well. This is how they're marked in the U.S. You know, caution, warning, danger. If up in Canada they mark them a little differently. Pipeline operators are required to provide a wealth of information to emergency responders that can help reduce the impact of release. And all this information definitely would help safely respond to a pipeline emergency is going to be one of the biggest ones there, and getting a hold of them as well. So here's an example of pipeline, petroleum and hydrogen pipeline. And just because it's marked there doesn't mean that's where the pipe is either. So that's, utilize those numbers on there to get a hold of that company. Just different tankers you see. We don't deal with these a whole lot in the Midwest, but you never know. Barges going down the river, things like that aren't quite as big, but still potential hazards. Then you got your really big bulk carriers, barges, and then unit loading devices. I mean, they have all kinds of different product on that. So you can see they have a type of list or manifest there to help you identify what's on there. Intermediate bulk containers. See these a lot in some of those print shops and things around here. They got different liquid and things stored in those for their big, massive printers. They transport a wide variety of material and hazard classes, including all the above, but it looks like corrosive is up there, and then aviation fuel and gasoline up there as well. So very, very hazardous materials. So then you have your bulk containers, flexible and then rigid. Drums can carry up to 55 gallon are the most common, but they do come up to 119. Typically metal carry flammable and solvents, and plastic carry polymer or carry corrosives. So have open heads or tight closed heads. So learning objective 11 we're going to go over is describe the ways transportation placards, labels, and marking indicate the presence and hazards of hazardous materials. All the placards we've been seeing on all the different trucks and things, and how to use them to identify materials. So you got your labels and placards. These are the 9 UN hazard classes: explosives, gases, flammable liquids, flammable solids, oxidizing substances and organic peroxides, toxic and infectious substances, radioactive materials, corrosive substances, and then miscellaneous dangerous substance and articles. There's some examples of that right now. Often displayed on placards, orange panels, and certain markings. In North America, these must be displayed on rail tank cars, cargo tank trucks, portable tanks, bulk packages, table 1 materials, and certain non-bulk packages. And those are found in the yellow border of the ERG, which we'll go over. Here's an example of one. You got your background color, what hazard it is, where to go to start off in the ERG to deal with the hazard. Very good tool. And then, you know, explosive, oxidizer, flammable, red, white, health hazard, blue is water reactive, non-flammable gas is green. And if you forget those are all in your ERG as well. And then the different hazard symbols there. Explosive, oxidizer, radioactive, flammable, poison, corrosive, non-flammable gas. And then, this is just an excerpt from, the ERG. Just another tool to help you mitigate an incident or see what you're dealing with. So 2810, there's your placard there on that, how that correlates to the dangers there. So we'll go over a practice one and show you guys how to use the ERG properly and get you comfortable with it. More examples of different labels. And this one has a couple different ones because it's flammable and toxic. So flammable 6 is very bad. So 6 is the highest. Different markings that you may encounter that you might want to be familiar with. And then objective 12 is the hazard class. So we're gonna go through those. We saw a bunch of them in the pictures and we'll touch on them all. You know, class 1 explosives, class 2 gases, class 3 flammable liquids, class 4 flammable solids, class 5 oxidizers and organic peroxides, class 6 poisons, poison inhalation hazards, and infectious substances, class 7 radioactive materials, and class 8 corrosives, and then class 9 was your miscellaneous. So here's your reactivity. Your reactive, any substance with potential energy that may rapidly expand and release upon activation. And then release energy in the form of light, gas, and or heat. Some are not specifically designed to explode. So there's your division, compatibility number, your explosive placard on that one. Your explosive hazards, blast pressure, shock wave, the fragmentation, shrapnel we've talked about from explosion, seismic effect, thermal and chemical, self-contamination, and then shock and friction. So not only will the explosion get you, the shock front can get you, and all the shrapnel and the thermal effect from the incendiary. So a lot of different hazards on those. Here's your gases placards, examples of those. Like you saw, similar to what we looked at earlier when we were going through containers. And those are cryogenic as well. Potential hazard, corrosivity, energy, toxicity, and then the gas vapor. So all 5 different hazards of gas, chemical, mechanical, cold, asphyxiation, and heat hazards. And then flammable and combustible liquids, primary hazards, energy, corrosivity, and toxicity. So thermal and hazard heat is going to be your biggest thing from the flammable and combustible, but those are all other hazards too. Asphyxiation because of oxygen depletion from the incident, chemical hazards depending on what actually combusted, your mechanical hazards, vapors, and then environmental hazards. Class 4 flammable solids, spontaneous combustible, and dangerous when wet. Example of those placards there. And then your oxidizer placards, class 5. And then here's the dangers of oxidizers. Vigorously support combustion. They may be explosive, not necessarily. May burn continuously when combined with fuel. Some have the ability to burn continuously without air being present. So, those are very dangerous as well. Organic peroxides, oxidizers with a chemical composition that makes them prone to reactivity. Small amount of heat will start a fire or explosion, both the fuel and oxidizer is reactive. Stored below the maximum safe storage temperature, which is very important, and undergo a chemical reaction and may violently release from their package if they reach the self-accelerating decomposition temperature. So temperature control in those is very important. And then your primary hazards, thermal, mechanical, chemical. Poisons, poison inhalation hazards, and infectious substances. The old skull and crossbones there. It's kind of a dead giveaway on those. And then you can see on the placards there, they're displayed their inhalation hazard, it states. And on the taped one as well. poisonous materials, toxic to human, avoid contacts, toxic vapors that can be lethal if inhaled or inhalation hazards, and then infectious substances and biohazards have the potential to cause disease in humans or animals, typically shipped in small containers with a label but no placard. And then your radioactive material, it requires specialized monitoring and detection equipment because, as I said earlier, you can't detect it by any of your senses. So you have to have specialized equipment to detect those radiation levels. Must be labeled on two sides, and then there's three different labels. There's white, yellow, and yellow 3 there. Yellow 2 and white 1, I'm sorry. So there's some more examples of radioactive material placards. Your corrosives, liquid or solids that cause full thickness destruction of human skin within a specific period of time, or liquid that has a severe corrosion rate on steel and aluminum, so very nasty stuff. Can't cause fire or explosion if they contact other materials. They do react with metal to, some react with metal to form hydrogen gas. Different types can react violently when mixed with together or combined with water, so they do have some water reactivity possibly. And can be toxic, flammable, reactive, explosive, and or oxidizers. So, like I said, very, very dangerous stuff to deal with. And then your miscellaneous placard, anesthetics or other similar property, hazardous substance or hazardous waste, elevated temperature material, marine pollutant, primarily have thermal and chemical hazards. And that's just an example how, for Canadian markings on placards, no signal words, and they might be, I'll bring this up because international truck drivers too could be doing this as well. I don't speak French, so that might be tough if they're from the Quebec area. Requires unique placard for anhydrous ammonia and inhalation hazards. Radiation placard may have the 4-digit UN number, may have. Hopefully it does. And then just some examples of Mexican placards as well. It's pretty similar as well. You can obviously tell just from looking at those, there's some kind of danger on those, so it's a good heads up. Everybody good? Anybody need a break, or you guys okay? Okay. Objective 13, other markers and colors indicate presence of hazardous materials. You'll see these a lot of businesses, a lot of commercial, industrial, even some restaurants and things that have these up for warnings on any chemicals or hazardous materials that they have. And then there's your NFP 704 system. So 0 being the most minimal hazard, 4 being the worst on each of those hazards, health, flammability, and then instability in yellow. So then special hazard symbols, unusually reactive with water, and then OX for oxidizer. Your globally harmonized system, it promotes common consistent criteria for the classifying chemicals according to their hazards. Uniform classification of hazard substances and mixtures, uniform labeling standards, and uniform SDS content and format, trying to get everybody on the same page. So like it says globally, so we all have the same standard of labeling product. So there's no confusion on what we're dealing with. And there's your warning labels on that, and they're pretty self-explanatory on those as well, but it's good to review them for your flammables, oxidizers, explosives, corrosives, compressed gases, warnings, just a general warning, environmental, poison, toxic, and then a whole variety of health hazards on that one. So, per OSHA, employees must identify hazards in the workplace. They are required to train their employees how to handle those and ensure all hazardous materials and containers are labeled, tagged, or marked with identity and the substance and appropriate hazard warnings. You'll probably run into places that don't follow all of OSHA's rules, so that can, sometimes you don't know what's in unlabeled bottles at all. So always take caution when dealing with that. So there's a little example of the Canadian workplace hazard system. And then military bases, which there's some military bases close to here. using their fixed facilities, maybe vehicles not uniform. For security reasons, not all hazmat will be marked. And here's an example of some military markings. I would imagine if we go to any large incident at a military base, you're gonna have to have liaisons and other things and get it talked. They usually have their own fire departments and things that you can assist. And it'll assist you on identifying things, since we don't use these a whole lot, not real familiar with them though. Red, you're dead, yellow, you're mellow, and white is bright. Pesticide labels, you've seen these, are all over the place, they're required, even on your home stuff. Just precautionary statements, identifier, signal words, supplier identification, what the label includes, and you can open that up and it'll fold out and give you a lot more information about like that's a turf herbicide, about the product that you're dealing with. PCB warnings. So always good to have, like this one's through Dow Chemical, utilize those numbers on there. They're gonna have a lot more in-depth information on what you're dealing with than just out of your ERG. ISO safety symbols, pretty similar to the other ones, biohazards in there. And then the irritants X is the only one that's a little different. And then your color codes, obviously red, danger stop, orange warning, yellow caution, green safety equipment, and blue is safety information. So we have, learning objective 14 is describe the ways that written resources are used to identify hazardous materials and their hazards. Fixed facilities have the SDS sheets we talked about earlier, inventory records, facility documents, signs, markings, container shapes, and other labels. Depending on how well the facility is run or how they follow rules, those might not all be in place, so always use caution at fixed facilities. And then transportation incidents, ERG, and other written resources are great tools to use on those. And then this is the ERG that you guys went over before class a little bit. I sent you, I know you touched base on a little bit, but we'll do an example here. Your 4-digit UN number is yellow bordered. Your blue border pages is the name of the materials involved. And then your table of placards and initial response guide for VG is a transportation placard and 3-digit guide code. White pages and orange border pages are the container profiles. So I don't know how, put on there with duct tape. I don't know how well that's gonna stay on there, but you can obviously pull up on your guide number 1247 in there, and it'll get you to your proper page on how to handle the incident. And then there's a lot of things that your white pages go through here. All your safety precautions, your hazard numbers, rail car identification chart, a lot of information in there. The user guide, protective clothing, levy safety precautions, glossary, and then other response telephone numbers and things. Here's your ID number, your yellow border. So, and that'll get you to the next part to help you assist you with the ERG. And there's that P for indicate that it polymerizes. I don't know if there's one on there, but there's a P. I don't think there's one on this page. I don't see it, but. And then inhalation hazards are highlighted in green on those. And then there's your blue border pages. That'll be if you have an actual material name and not just a guide number. You can look it up that way. And then here's what helps you out the most once you find out what you're dealing with. Your initial action pages goes over health, explosions, evacuation distances, PPE, lots of first aid, lots of different information. Right here. Health hazards, like I said, a lot of good information. Your initial isolation distances, what to do if it's on fire, if it's just a leak, a lot of different information. Depends on the material you're dealing with. So, just like we covered there. Like, just an example, if you have a liquid spill, which way the wind's going, it's gonna tell you which way to evacuate. You're not gonna wanna go against the product, you're not gonna wanna run downwind from it. And then your initial isolation distance of a chemical, that's 100-foot radius there, 100 feet all directions. Or, you know, it's your protective clothing, it'll go over what's most appropriate to wear, or what rescuers and things will have to wear to deal with that product. Like I said, we'll touch on this, we'll go through an example before you guys do your practical on it. It goes through the response section, the fire section, spiller leak, first aid. Every guide number's different, so there's gonna be different actions for each guide that you bring up. And then there's your green board, there's the green with the vapors, and then there's your isolation and protective action distances in the green border pages for each different chemical. So, the bill of lading on some of these shit, if you can get to them, if it's possible, the bill of lading will have that contact number that can help you out with the situation you're dealing with as well. So, just all things you're supposed to have on there. Hopefully it's filled out properly, that way you can utilize it. So then there's an example of the SDS sheets we talked about, very helpful as well. You can get the exact product that you're dealing with and the different classifications. It's got its symbols there of its dangers, things like that. And so those are the different things on the SDS sheets: identification, hazard identification, composition information on ingredients, first aid measures, your firefighting measures, accidental release measures, handling of storage, and then exposure controls and personal protection. Physical and chemical properties, stability and reactivity, toxicological information, ecological, and then disposal considerations, transport information, regulatory information, and other information. Like I said, those have a lot of information on them. So, and then facility documents, if you're able to get those too, that's another good tool to help you identify and mitigate a scenario. And then your local emergency response plans, designed to provide a forum for emergency management agencies, responders, industry, and public to work together to evaluate, understand, and communicate chemical hazards in the community. And then develop appropriate emergency plans in case chemicals are accidentally released. It's always good to have that plan in place. Better to practice it and have one than to wait till something actually happens. So, I know there's a lot of content to go over. So if you guys have any questions or concerns, even after you leave class, I gave you my cards, contact information, that email. You can always email me or call me, my number's on there as well, if you have any questions or concerns. But if not, we'll take a real quick break, and then we'll go over one ERG scenario, and then we'll get to your practical and your written test, and I'll explain all that too. Okay?
Alright, sounds good.
You guys can go over here.
Oh, I forgot, yeah.
You need to use the bathroom.
Doing all right? All right. There's waters in here if you need them. Everybody good?
Yep.
No issues, okay. Alright, like I said, we're just gonna go through a, little placard training thing here. You have your ERG guides, so you get to, an incident, and this is a placard that you find on a container. So like, if you could, Steven, do you have a guide number on, this placard in the yellow section? It'll, you can kinda see what we're dealing with on here, so your number's 1219.
So that'll be guide number 129.
Yep, so then you would go to your, orange pages. And that's gonna give you all your different,
Highly flammable.
okay. Like 3 different things from there, for potential fire explosion hazards.
You said highly flammable. Vapors may be from explosive mixtures with air. Vapors may travel to the source of ignition and flashback.
Okay.
And most vapors are heavier than air.
Okay. That's very good information.
It's designated with a P, may polymerize explosively when heated.
Okay. Samuel, any potential health hazards on that?
Can be toxic if inhaled or absorbed through the skin.
Okay.
Inhalation or contact with material may irritate or burn the skin and eyes.
Okay.
And the vapors can cause dizziness or asphyxiation, especially when enclosed or confined areas.
Okay. Landon, what would be, initial isolation for a leak or a spill on that? Your distance?
Distance. Eliminate all ignition sources from the.
But what would your distance be for a, large spill, or, your initial spill or leak, anybody can jump in, it's just practice.
Be 1 mile?
No.
So under the evacuation part, I guess, there, is that where we're
Yes,
putting that?
yes.
Okay.
Sorry, I might have misspoke on that, I'm sorry, I was doing the isolation.
Oh, I'm sorry, I thought you meant,
Distance to isolate leak spill area in all directions for a given container and material ID.
at least 50 meters,
Okay. Which is about
150 feet.
150 feet. And then your, if the material's on fire, what would be your distance in all direction?
800 meters, half mile.
Yep, half mile, good job. And then recommended PPE, you guys can, anybody can answer. Recommended PPE for this hazard?
Structural firefighting gear,
Okay.
and SCBA.
Okay. It is limited chemical protection, though, don't forget that. And then on a small fire, what are a couple agents we can use for extinguishing?
Dry chemical,
Yep.
CO2, water spray, or alcohol resistant.
Okay, awesome. What about large fire?
We use water spray, fog, or any alcohol resistant foam for
Yep.
that too.
Awesome. And then what if we have a fire involving a tanker? Or involving tanks, excuse me.
Fight the fire from maximum distance, use unmanned master stream devices or monitor nozzles.
Perfect. You guys got the hang of this. What about a appropriate response for a spill or a leak?
Eliminate all ignition sources, all equipment used when handling the product must be grounded, do not touch or walk through spilled material.
Perfect. And then, some first aid measures you might have to take.
Call 911.
Excluding 911, sorry.
Ensure medical personnel are aware of
Always wash your skin with soap and water. And if you get burned, cool the affected area with cold water.
Perfect, perfect. I think you guys are pretty comfortable with that. If you guys, unless you don't have any other questions, or if you wanna review anything or go over anything, I'll hand the practical and the quiz out. Take your time doing it. If you have a question or something you need answered, just raise your hand, I'll come over and help you individually. And, I'll give you guys time to do that. Quiz. Like I said, if any questions at all during that, feel free to raise your hand, I'll come over and help you out. And this will be for when you're done with that, use your ERG to fill that out as well. And you guys are done, just, I'll collect them, I'll grade them, and then I'll go over them with you individually. Bless you.
Thank you.
Need a tissue or you okay?
Oh, all right.
about everything today. Like I said, any questions or anything you need to touch over? Everybody did really good on the tests, whatever. Couple things I had to show you guys on there, but no big deal. You guys did a really good job. Everybody comfortable with the ERGs? Okay. Awesome. Well, I appreciate your time, and, like I said, still more water and snacks there, or, you got my numbers and my email, so just, get in contact with me if you have any questions, and I appreciate you guys. Thank you.
Thank you.